Okay, so for this one, it's a little weird. We have to go back to how to solve word problems. I know it's a really complicated thing to do, but I just want to make sure we're totally good. This is what I call the Burger method. You see this same method often in writing and in English classes, but we can totally apply it to math. So, for my burger, this is how I think of all word problems. For my burger, I'm thinking, what does the problem really ask me? Word problems are often somewhat confusing and not very clear. I need to pull out exactly what it's asking. Then, I'm going to say, okay, what are the facts from my brain? Sometimes our problems do not tell us everything we need, so we need to extrapolate some new information using previous knowledge. Next, what are the facts from the problem? We have to read our problem, figure out, okay, what's the important info from here? We might have to inject some ketchup, some work. And then finally, what is our answer? Now, the reason I have the answer and the question as the same, because our problem, what it really asks, needs to match the answer. So if we're asking about how many, I don't know, let's just say centimeters there are, my answer needs to be in centimeters. I can't be asking for centimeters and then give it in meters. I need to make sure I'm totally on the right page. And so that's why bread matches. So let's take a look at this problem down here as an example. I'm going to read this and annotate while I'm doing it. There are 10 feet. Oh, I know that's an important piece of information. There are 10 feet. How many inches are there? Pretty straightforward. The bread. What is the problem really asking? I know it says, how many inches are there? I have 10 feet. So I'm going to say, how many inches are in 10 feet? That's what I'm thinking about it. How many inches are in 10 feet? Next, what are the facts from your brain? That's my veggies. I see feet, I see inches. My problem doesn't tell me how many are in each, but I know from my brain that there are 12 inches in a foot. What are the facts from the problem? I'll look back at my annotation. I circled 10 feet. I know there are 10 feet. For my work, this is my ketchup part. I know there are 12 inches in 1 foot. I know I'm going to 10 feet, and I need my problem in inches. So I know 1 times 10 is 10, so therefore I have to make them match. 12 times 10 will be 120. So my answer with units will be 120 inches. That's how I solve these kind of problems. I'm going to do one more in the back just to make sure we're totally set. Okay. This one says the ratio of girls to boys is 3 to 1. If there are 6 girls, how many boys are there? That's how I skillfully annotate. I make sure I write down all my notes so I'm not confused. My bread, what's it really asking? How many boys are there? Pretty straightforward. How many boys are there? So, given that question, I'm not going to tell them how many girls there are. They don't need that information. They need how many boys are there. Veggies, how's that information? I'm going to suggest how to solve a ratio problem. My meat, I have 6 girls. Also, my ratio of boys to girls equals 3 to 1. Oh, I messed up. Girls to boys is 3 to 1. Everybody makes mistakes, myself included. Ratio of girls to boys is 3 to 1. Girls to boys is 3 to 1. Now I do my work. I set my ratio 3 to 1. Girls to boys. I have 6 girls. How many boys do I have? I'm going from 3 to 6, so that's going to be times 2. So I have to make these match. Times 2. 1 times 2 will be 2. I will have 2 boys. 4, 6 girls. So my answer, my bread, will be there are 2 boys. That's how we do this kind of thing. If anybody ever asked you to rationalize it in words too, you have it all set up here. You can say the question asks how many boys there are. I know this is a ratio problem. If there are 6 girls and the ratio of girls to boys is 3:1, I know that 3 times 2 is 6, so 1 times 2 equals 2. So there are 2 boys for every 6 girls. The answer is that there are 2 boys. You've set up your whole reasoning right here, and you solve your problem at the same time. Why not get 2 in 1? That's how you solve these problems using the Burger method. Have a good one.